My name is Karthik and you are watching Technical Q. So today we will be learning Microwind software. Microwind software is used to make layouts. So the system which you are learning today is CMOS inverter. You know inverter is a NOT gate. So whatever input you will give, if you give 0, it will appear as 1. So to implement this system using CMOS, CMOS is complementary MOSFET. So one PMOS and one NMOS together is known as a CMOS, complementary MOSFET. So as you can see, a PMOS source terminal is connected to supply VDD and drain terminal of both PMOS and NMOS are shorted and output is taken from both the drain terminals and input is given to the gate terminals of PMOS and NMOS. So A is the input. So if you give A as 0, Y will appear as a 1 because A is 0. So it will turn on PMOS as there is a bubble here. So for 0 input PMOS turns on. For 0 input NMOS turns off. Okay. So as we have given 0 to A, the supply will flow from PMOS and it will appear at the output. So we have implemented CMOS inverter. So now we will learn how to implement the layout in Microwind software. So as you can see, this is the Microwind software. So the screen will appear like this, and here you have to take one PMOS and one NMOS. In palette you can see an option here. It will click just on the icon and go here PMOS. So select the device and generate device and click on the screen. Okay, this will appear and it indicates a PMOS. Now you have to cut it and paste below. Okay, so what I have done, I have selected this option stretch and move and I have selected the component and dragged it down. Okay, this is the PMOS and this green rectangle is known as anvil. So there is a rule that you have to always paste a VDD supply in anvil. So from here you can take the VDD supply. I have taken it and I am pasting a VDD supply here. So it is compulsory for every PMOS to drag down a VDD supply in the anvil. So this does not relate with our system. I have by mistaken pasted some metal here, so you can undo it by pressing Ctrl and U. It is not Ctrl and Z, remember that. Okay, so I have taken PMOS. Now I will take one NMOS, generate device. Okay, I have pasted here, and similarly I have to cut it and drag it below. Stretch and move. I have selected stretch and move. Okay, I have moved it. So the three layers you are watching here. First is the metal one and gate. Metal one is blue color, gate is orange color or you can say red, and here it is also metal one. So this polysilicon orange layer indicates the gate terminal, and this device, as you know, it has a NVEL, it is a PMOS, and you can see in diagram PMOS is always connected to source is connected to VDD and drain is connected to output. So remember that CMOS terminal which is connected to supply is source and current flows from source to drain. Okay, so we have to connect a VDD supply to source, and here is the source. Okay, this is the source, current flows from here to this drain, and we have taken output from drain. Okay, we have to short these drains. Now I will short these drains. It is metal one, so I will select metal one from the palette and I will just drag it here, so they will be connected. Now I have to give input to gate, but I have to short both the gates. As you can see in the diagram, I have shorted both the gates. Okay, so select polysilicon here and paste on the gate terminals. So gates are connected. To give the input, you can select one of the inputs from these options. Now I'll select one clock. Okay, and I'll paste on the gate terminal. So this will act as an input. I'll give a name, input, assign, and to watch my output I'll click on visible node. a symbol which looks like I and paste it here on the metal one, because we have shorted both the drain terminals, and here I am watching my output. So it's not pasted correctly. I'll paste once again. Okay, and I'll name it as output assign. So we are done with the layout. Now we'll just run the layout. Before running, we have to do one procedure, that this is a design rule checker. It will check whether width of one of my layers is small or not. Some errors might introduce because of length or width. So this will check that. Now we'll run the layout simulation. Okay, there's something wrong went there. Oh yeah, I forgot to give a minus VSS. This is the mistake I've done. So go in the view and palette of layers, and here you can select minus VSS. Okay, which is basically a ground. So I have to ground the source terminal of NMOS. Now it will run. Okay. So this is the output, but we haven't seen the input. Okay. So I have to make the input visible in the output. I'll double click on the input, and I have to make this visible in simulation. Okay. Now it will show the input. Once again assign. I'll run once again. Okay. We have got the output. Now I can change the scale. Look here now. For one input, we are getting no output. So for one, we are getting 0, and for 0, we are getting 1. So thus we have implemented a NOT gate or CMOS inverter. So for more circuits, please refer to my next videos. Please like, comment and share the video, and subscribe the channel. Okay, thank you.